This is the solution video for Midterm Exam 1, Problem 1. And in this video I will not be writing everything for the solutions because some of these will just take time to write. So I'll just explain what I would write and you'll be able to see the final version in the PDF. And so to start, we have solve the following Boolean operations. X, XOR X. So this is equal to essentially X, X bar, or X bar, X, which we know this is 0. We know this is 0 by the complementarity principle. 0 or 0 is 0. And now we have X XOR 1, which is going to be X or 1 bar, which is 0, or X bar and 1, which is just going to be X bar. Because that's going to be 0, and this is just going to be X bar. And now we've got X or X bar. So that's pretty much going to be the opposite of this. So basically I'm going to have X and X, or X bar, X bar. So that's equal to X and X, which is X, X or X bar, and X bar is X bar, so X or X bar is 1. Then I have X or 0, so that's going to be X, complement of 0 is 1, and then X bar with 0, so that's going to be equal to X. Now, part B. Define a static 1 hazard and explain what causes it to happen. So this one I will not write down. Define a static 1 hazard. Essentially, anytime you have a change in the inputs, that should cause a constant output. However, the output will have a momentary glitch to 0 because of a difference in gate delays between the inputs and the outputs. So different inputs will have different paths to the output, and they will not have the same amount of delay, which causes the glitch. State the principle of duality. So this one's fairly easy. So if expression 1 equals expression 2, then the dual of expression 1 equals the dual of expression 2. There's not much more to explain there. Define overflow and explain why it happens, and give an example. So I won't write this. Define overflow. So overflow is essentially a limitation in hardware caused by the fact that we can only represent a certain number of bits in a register. And anytime we do an addition or subtraction that causes us to go too positive or too negative such that we exceed the limitations of the number of bits we have to represent a number, our output of that operation will become wrong. And so an example would be something like well, with unsigned, 3-bit unsigned, you have 1, 1, 1 plus this, so this is just going to be 0, carry the 1, 1, carry the 1, 1, carry the 1, 1. I think that's right. Yeah, that's right. And so my answer would just be this, and this would be overflow. True, false. A circuit can output a don't care. A circuit cannot output a don't care, because as soon as you implement a circuit, it will either output a 1 or a 0. So this one is false. And now we have order the following numbers from largest to smallest. And so essentially here we want to convert everything to a common base. So I would say base 10 is probably our easiest base to work with. So this is going to be 10.5, base 10. This is going to be 32 plus 3, which is 35, and 3/16. I'm actually just going to write 3/16 right now. Base 10. And then we have 8 plus 4, which is 12, and 3/8. And now we have 5 times 6 is 30, plus 5, 35, and 4/6. And we have 12.4. So that is, we'll keep that the same. So all these are now in base 10. And so from largest to smallest, so 35 and 4/6 is the largest. So 55.4 base 6. And then 35 here is the next largest, so that's 23.3 base 16. So 4/6 is much bigger than 3/16. Then we got 12 and 3/8 and 12.5. So this is less than a half. So this is, oh goodness, oops, 12.4 and 14. I can't copy. So this is 4/10, and this is 0.375. So this is bigger. And then we have 14.3 in base 8 and 1010.10 in base 2. Alright, solve the subtraction problem using 2's complement binary and the multiplication using unsigned binary. So I don't want to do subtraction, so I'm just going to convert, well, this is just going to be this, and I'm going to convert this into a positive number, and or take the 2's complement and add. So I complement every bit, so that's going to be 0, 1, 0, 0, 0, plus 1, so that's plus 0, 1, 0, 0, 1. So this is 0, carry the 1, 1, 1, this is a 1, 0, 0, 1, 1, 0, 1, 0, 1, and that should do it. And then I've got my multiplication. So here I've first got this first row is all zeros, and then 1, 1, 0, 1, all zeros, and then 1, 1, 0, 1, plus. So 0, 1, 1, 1, 0, carry the 1, 1, and 1. So that's my multiplication. And that completes this first video.